Hi guys, welcome. I have created a blockchain lab, and in this lab we are creating a smart contract on Ethereum. You can see the URL of my GitHub repository over here. If you're going to contracts, we will be playing with the simple lottery source code. If you push raw, we just select the code, and in Ethereum there is an IDE called Remix. And that's an online editor. You don't need to install anything, you can just call it online. So it remembers the stuff you have created before. In this case we are going to create a new example called simple lottery, and I'm pasting the code I just copied. So let's go over the code a little bit. You see the IDE compiled the source code. It gives some warnings. It's pretty strict. It's up to you guys. So let's go over the code very quickly, so you have a sense and an idea of what this contract is doing. Here you see the name of the contract, and it's not implementing any interface or anything. It's the same thing like Java, but instead of a class you have a contract. By the way, this is all written in Solidity, and Solidity for now is the default language for Ethereum. Here I'm defining some variables. What's very important is that you can create your own struct, and a struct is your own data type. You will see it later on. This variable is also important. It's a mapping, and this mapping contains basically an array of balances for all the Ethereum addresses in there. A nice thing within Solidity, you can define a modifier like public and private. You can also say I'm defining a method or a function, and this method has this modifier, meaning that this method can only be called if it meets the requirements within this modifier. So any method that implements this modifier needs to have the requirement fulfilled that no lottery has won, and the sold lottery number variable is equal to the number of tickets. This thing, I forgot the name how it was, but fallback always needs to be called within Solidity to enforce this modifier. This is another example where I say any method that has this modifier can only be called when the tickets sold is smaller than the number of tickets. So this is an example of a struct, and this struct lottery client contains 3 properties. So you don't need to create any bean with getters or setters. You can just call this struct and with this property. Okay. Here I'm defining some arrays with a lottery sold lottery numbers and unsold lottery tickets. This is a function within Ethereum which has the constant, and when it's constant it means that it doesn't generate a transaction. So this method is typically an example of an Ethereum method that is not changing the state of the contract, meaning that it's not changing the that is not needs to generate a transaction, because when you call the show winners, it doesn't change the state of the contract. It just shows you what's currently in the winners variable. This is the constructor, and this is the way you initialize a new contract. And the constructor, of course, has the same name as the contract. So when you call this or generate this contract, you initialize it with an initial number, and this number is being used to fill in an array of unsold lottery tickets, and per ticket it will generate a random number. So this is my implementation or my idea of a fair lottery. And the lottery is initialized with an array of numbers, and these numbers are already randomly drawn. So here you see how the random number is defined. It's using a seed, and in this case, because it's a very simple contract, it's a number between 0 and 10. So let's go back. Then what's important to know that there are also transactions within Ethereum that implement Payable. And when something is payable, it can actually interact with your wallet. And the wallet is basically the stuff you need to have. It contains your private keys, but it also should contain your Ethereum balance. So in Bitcoin you have a collection of it doesn't store anything in your wallet. It's just a sum of the input and output transactions that's in your wallet. But the main thing is that it contains your private keys. So with this wallet, basically you can perform a payment. I will show you later on which wallet we are using. So this buy ticket method is actually calling a method that is able to deduct something from your wallet. This is my this is something I have written that I said, okay, you can only call this method if you are paying 1 Ether, and message.value is one of those internal solidity variables you can use to determine what's being put in the dialog of the transaction. So if everything is okay, I'm manipulating the array, and you can see, because I'm manipulating it, it will change the state of the contract, and therefore it will need to generate a transaction. And basically what it will do, it will add to the sold lottery number the lottery client with the random number, which is one of the unsold lottery tickets. And this one is also important. The message sender is basically the address of the client who's actually buying this ticket, who's calling this method. So in this case, if I'm a client and I'm having this wallet, then it will use the initial wallet address for this. This method is always important to implement if you have a payable contract. And then we have the last method. It's called getWinner, and basically what it will do, it's so for example we have initialized this contract with 10 tickets. Then 10 people need to buy a ticket. The Ethereum, this contract will contain 10 Ethereum, and it's possible that maybe the winning number is 7, and that there are 3 people who have the number 7. Then it will divide the 10 Ethereum with 3 people, and everybody will have an equal share. The last thing you need to know, that there is also a concept of events, and an event is basically a method which is being used in Ethereum to communicate with the calling interface. And the interface we will be using in this demo is the browser, the Solidity interface. So let's start running it. We go to the Run tab, and when we go to the Run tab, you will see we can do it in JavaScript VM, injected Web3, or calling the Web3 provider. So let's start with the JavaScript VM, and that's basically the quickest way to develop and test your code. So we have loaded this. You see, when you call this JavaScript VM, initially you will get 6 accounts with each of them 100 Ether to play around with. So I will call this method the constructor create, and it has created the ticket or the contract on the blockchain, and it has created it with this address. I can copy it by clicking this button, and I will show you what it is by going here. This is the address of my contract on this blockchain. So let's buy some tickets here. Chris, please remember to put the variable between quotes, and also don't forget to put 1 Ether as paying. as a value here. So you see that I have currently 99.99. Initially I had 100 Ether, but because creating the contract cost me gas, I now have 99.99 Ether in my account. When I'm calling the buy ticket method, I will have 98.99 Ether because it cost me 1 Ether. And the 1 Ether is being deducted from my account and it's added to the to the to the contract. And I can see that by calling show contract ETH that I have currently 1 Ether. The zeros are just decimals between the for Ethereum value. Ethereum has standard like 18 zeros behind it. So I'm buying a second ticket. It's also 1 Ether. And here you see I have now 2 on my contract and it's deducted from my same account. It's now 97.99. And the last one is pick. I will create another one. So the nice thing about this thing is when you go to the events, I'm going into the details and I can see here that Lotte has bought a ticket and the ticket has the lottery number 1. And here, let's see here, I was the first one and I have lottery ticket number 7. Let's go to the last method. Here you see Puck and she also has number 7. So in this case it's quite well possible that the winning ticket number will be number 7 and the prize money of 3 Ether will be divided by 2 people. So let's draw a winner. By the way, you can also do a debug and the debug is quite cool. When you click on this, you can see step by step what's happening and evaluate the variables like you would do with the normal programming language. So, but forget about it now. It's quite handy if you need to look into your code or see what's happening. So let's see, we have now 3 Ethereum. We're going to draw a winner. What happened here? So the winning number was 5. Nobody has it, so we need to redraw. Let's do it again. Details. Nobody wins. Let's do it again. Nobody wins. We will keep going on. This is the 4th time. Now it's number 8. Nobody wins. Let's call again. Again an 8. That's quite well possible. That's number 6. Number 2. So we will keep going on. Number 5 again. Number 5 again. Come on guys, nobody's lucky here. It looks like a real lottery. Nobody ever wins. And finally, after 11 times, we have found a winner, and the winner is number 7. And as you can see, this is my Ethereum address, and the Ethereum will be distributed back to the initial address. As you will see, it has been redeposited to my wallet 99.99. So this is what I had initially. And the winners are Chris and Puck in this case. So let's do it on a real test network. And this is also a test case how you can do it later on the real Ethereum network. What you need for this is a wallet that is integrated within your browser, and the people mostly use MetaMask as a Ethereum wallet. Go to metamask.io, download the extension, and if you have downloaded, you will have a nice little looking fox in your browser like this. So this is the wallet what we have. As you can see on the left top, you can select which network you are using. And the Robson network is one of the networks that is being often used by Ethereum developers, because this one uses the proof of work consensus algorithm. Within this account or network, I have 3 accounts. You can create as many as you like. And as you can see, I already have some Ether on this test account. If you don't have it, just click on the buy button and then you will be redirected to a faucet. And a faucet is just a test tool that will give you Ethereum to play with. So if you just push the request 1 Ether button, you will see it generated a transaction, and it will by default send 1 Ether to your MetaMask wallet address. And your MetaMask wallet address is this address. So you can show the QR code. This is the address that is being used. So let's do it again. And now we should have 2 extra Ether in our wallet. One is already in there. The next one probably needs to be mined. But let's get going on. So let's get back to the remix. We are switching it to the injected Web3 provider, and you can see it's now connected to my Robston network, and by default it's using my MetaMask wallet. And in my MetaMask wallet I have 8.22 Ethereum. Let's double check. That's correct, 8.22 Ethereum. So let's create the contract, and I will create it again with 3 people. A dialog from MetaMask will pop up because I need to confirm this transaction. So I will say I will spend 10 Wei. You see this transaction needs to be mined. It's pending. It's taking much more time than it will take on the JavaScript VM. So let me pause it for a while. So it's here. Let's buy some tickets. Chris, 1 Ether. Buy tickets. I need to confirm it. Here you see the 1 Ether coming back. It's the message.value variable. So this needs to be mined as well. And if correctly, it will deduct 1 Ether from my wallet. So instead of 9, you will see here an 8. So let me do that for the other 2 tickets as well. I'll be back with you if that's done. Let's see, it's done. It has deducted 1 Ethereum from my wallet. So, not I've created the contract. I've bought 2 tickets. I just remember that I like to show you guys also that everything is stored on the blockchain, because that's the whole idea of having this blockchain technology, of course. So what I will do is I will copy the contract of the simple lottery by clicking on this button. I will go to a website that contains the ledger. So it's a tool to see what's on the Robston ledger. I will paste the contract address here. And here you see that my contract was first created and it contained 0 Ether. Here you see the address of the owner, and that's my address. And you see that currently the balance is 2 Ethereum. First, I bought a ticket. So I bought a ticket with the name Chris, and then there was a ticket bought with the name Lotte. We can click on that. Here, convert to ASCII. You see some information here back. And what's also nice is that you can go in here and see the contract code. So it's possible to publish your contract code as well, but you need to do something for that. You need to verify and publish it. That's another topic, but it's quite cool because everyone can use your contract and see the code. So let's do the last one. Let's buy another ticket here. Buy ticket. submit. And let's see what's here happening. We bought a ticket. So this was the initial contract creation. Then Chris has the number 6. Then Lotte has the number 8. And here we see that the last one, Puck, has number 4. So now we have actual people with 3 different numbers. So we're going to, let's see if the contract contains 3 Ethereum. Yes. There are no winners yet. That's correct. And let's go to the blockchain, and instead of 2 transactions, when I refresh it, I should have seen 3 transactions. So that's all good. So I can draw a winner. And in the last example, you have seen that I get my money back. So if you really want to see it, let me just draw a winner. Hopefully it's quicker than the last time. We finally have a winner. Let me show you. It took me 15 times to draw, and finally I got the winner. And you see the winning number is number 4. My daughter Puck is the winner of 3 Ethereum, and because she's also the owner of this wallet, in this case she gets this amount of Ether on her wallet. So let me show you that all the transactions, like the get winner, so the drawing of a winning number, has also been registered on the ledger. I can show you this. I'll refresh the screen, and you see here, this is the initial contract creation. Then you see that 1 Ether has been bought by one buying a ticket, another one, and then you see all these transactions. Basically, those are all the get winner methods. So drawing who is the winner. And when I look in it, you see this is the function that's being called get winner. So I'm going back. If correctly, you will see that the balance of this contract has now become 0. And when I go to my own contract or my own wallet address, you will see I have my 9.2 Ether back again. So I hope you guys liked it. If you'd like to know more about Solidity and the programming language, go to solidity.readthedocs.io. It's a great site with a lot of examples. It's pretty well documented. So guys, start writing smart contracts, and hope you guys liked it. Have a nice day.